Hi guys, so today we are going to discuss about Parkinson gear tester. So what is Parkinson gear tester? Let me see. So this is, so first I would say the application of this Parkinson gear tester. So this is used to check the profile of, not profile exactly, check the center distance of the gear. So whenever we engaging the gears in gearbox, there will be a spindle available. So they are going to design the spindle distance. So for example, one spindle to another spindle having distance 50 difference. So this difference should be maintained. Otherwise, we cannot get a accurate performance, better performance. It raises vibrations in the gearbox, causes vehicle vibrations, or it may be any other machinery applications. So this center distance should be maintained exactly of the spindle. So it should not be affected by the gear which is attached to the spindle. Let me see the component of the Parkinson gate tester. So there will be a base, this is base, and this is dial indicator, dial indicator, and this blue color gear is going to test. So this is a test specimen. The gear is to be going to test, and this green is a master gear which is high accuracy manner manufactured gear and gear profile. So this is a master gear which is going to tell the profile of the test specimen. Okay, so it is correct one. So when it is rolling over or keeping rolling with this master gear, will give some results. Okay, so then there will be a dial indicator for a mechanical purpose, and this is a graphical purpose. So this is an electronic recorder. This is an electronic recorder, and this having a display, and this having a transducer which is attached to the this movable carriage. Okay, so then, so there will be a calibrated spring. So this is spring is very important term. So let me see in working. So why we need a spring? Okay, so this is a movable carriage, this is a fixed carriage, this is adjustable carriage, this is a fixed carriage, this is adjustable carriage. This is going to slide here and there. Okay, this carriage moves here and there. In the carriage only the test specimen going to be attached. So in this fixed carriage and adjustable carriage is used to fix the master gear. So it is adjustable only, not moving always. Okay, it will, we can move and we can tighten. So it will act as a fixed one after tighten. Before that we can loosen the screw and we can adjust the spindle. Okay, so this is spindle of, these are the spindles, this is the base. Okay, let me see the functions of the each and every parts. So first of all, dial indicator, it reads directly based on plunger movement of the dial indicator and shows the variations on the dial. Okay, there will be a scale engraving available, engraving. So this engraving pointed by the pointer we can get a distance variations in mm. Okay, then this is a transducer. So this transducer is sensing the signals from movement of this movable carriage of the test specimen. This signal sent to the electronic recorder. So this recorder records the signal and displays the profile waviness. How the profile waviness, that means how gear centers variations happen. So if it happen like this, there will be a, there will not be any constant center oil, there is a variations in center. So here over center, that is 51 plus mm happens here minus 4, minus 2 mm, that is 48 mm. So center distance may be plus and maybe a minus. For example, 50 distance we need. So if it is any error in the profile of the test specimen, it gives 51, 52 distance or it gives 48. So there will be some errors. So these errors can be either profile of the teeth, either roundness of the gear profile, what it may be, we cannot find. But this machine tells whether it has a center exactly or not, that's all. Okay. So this is a spring. Yes, this spring is a very important factor. So when in our application in gearbox, there will be two spindle I have said. In the two spindle, there will be pressure when gear teeth engage with each other. So two spindle have each gear on the spindle. These gears will going to merge each other, mesh each other, and transfer the power, rotation. Okay. During that time, the load acting on the gear, force acting on the gear will be in some pascal. Okay, it may be a 2 megapascal. Okay, for example, it may be a 2 megapascal. So this 2 megapascal tension is 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 pushed over the spring. The 2 megapascal tension may have this spring. So this spring manufactured with having a 2 megapascal tension. Then only we can use it for that type of gearbox. So this Parkinson gear tester spring is based on what type of force acting on the gears. So what type of magnitude, maybe a 2 megapascal, 5 megapascal, based on that the spring should be replaced and can be used again. So this, if it is 2 megapascal spring is attached here, we can test 2 megapascal forcing acting gear can be inspected. Over the 2 megapascal cannot be tested here because of tension as well as profile. We are based on the tension we getting the profile, whether it is keeping an exact center distance or variations. So if it is very loose and it may not show exact variations. It says exactly centers happens. Exactly there will be a 50 mm constantly maintained. But when we pushes undergoes the exact practical applications force, example 2 megapixel, like that we have to add the force here, then we have to inspect. So these two gears should touch, should mesh with force 2 megapascal, then only we can sense correctly, otherwise it will lead to error. Even after testing, there will be a poor performance, poor applications we can get as a output. So the testing requirement should be proper manner, as a testing should be as a practical. So practical procedures, practical forces, practical problems, all these things should be minded, keep on minded. Then we should design a tester and we should conduct a test. Okay. Hence, like that, Parkinson gear tester designed with spring which have a tension of the gears which is available in the gearbox. What type of forces may have the gearbox gears is designed by this spring. So the springs adds very major role in Parkinson gear tester. So let's we discuss working. So what happens, how it reads. Simple, very simple only. Of course this has very simple component, so operation also very simple. So this specimen working or test gear going into rolling with master gear. So when rolling happens, When two gears are rotating, messing with each other, there will be a carriage movement happens based on the oscillation of the two gears. So this master gear having very good accuracy level of profile machining, but this test specimen may not or may. So when any oscillation occurs, this carriage moves right side or left side. So this happens and this results center deviations. It's not a center, there is a variations in center. Okay, tells there is a variation center. How we can read? By means of this dial indicator. Whenever the gears oscillator comes left side, this shows higher amount of deviation, and goes inside, this shows lower amount of deviation. That may be a 55 is higher level, 45 is lower level. So we need 50 center distance, but due to oscillations, we can read directly from the dial indicator. Of course, we can get graphical representation by means of this transducer device, electronic recorder embedded with the transducer. This oscillation up and downs, exactly we can say the deviation center can be read by these up and down profiles by means of rotation with master gear. Okay, this profiles and this dial indicator shows the exact variations of the test specimen. So there will be a deviations in centers of this center of this specimen. So we have to machine exactly, or we have to manufacturing as exactly. Then we can again put on the Parkinson's tester. We can test again. We can identify. So if identifying with high level of waveness, so we get off the specimen and we went to machining process or manufacturing process, then we came to again and testing here. So after that, after fine finishing, we can get these type of graph. So these type of graphs tells the specimen okay, center distance is achieved better manner. So generally, how much deviations can be applicable, allowable is 1 mm difference. So deviations can be available up to 1 mm. 51 or 49 is allowable allowance for center distance of the every each and gear. So these type of Parkinson gear having limitations also. So this Parkinson gear tester is used to measuring up to 300 to 400 diameter gear specimen. So this Parkinson gear tester is used for measure a gear which is having up to 400 diameter. So above 400 diameter we cannot go into test here, because the size of the Parkinson gear tester is that much only. So we can use up to 400 diameter test specimen gears. Second one is this having a measurement which is not exactly, that means it cannot say this is the exact reason why this test specimen having deviations in center distance. That means it gives result as a composite. So center distance deviations happens by means of many type of errors, like profile teeth error, like flank, like center spindle attachment area. So each teeth may have a variations in the size of the teeth. So these things may happen. Also the surfacings of the teeth also gives the variations in center distance. Okay. So these type of errors can combine to the results the center distance deviations. The Parkinson data tester cannot give exact problem of the center distance deviation. It tells only combination of the problems as a result. Okay. By this problem only it get deviations, like that Parkinson gait test does not give result. It gives just a deviations happen, deviations not happen. This gear placement having a deviation, this gear placement not having a deviation. That's it. It can tells, but it cannot tell exact problem behind the deviation. Okay. So this is the Parkinson gait test. Thank you guys.